What's up, scholars? We are continuing our discussion of multiplying polynomials, and we're going to start off with some properties of exponents. Our first property is that anything to the 0 power equals 1, so long as that anything does not equal 0. So a little note about this. 0 to the 0 power, 0 to the 0 power, doesn't have a well-defined definition. Some people say it equals 1, and some people say it's undefined. Is undefined? Is 1? But we're not going to get into that mathematical debate. We're just going to say anything to the 0 power is 1, so long as that anything is not equal to 0. And we'll leave it at that. That'll be good enough for what we're doing. Our next property, we'll say a to the m power times a to the n power, such that the bases are the same, means we'll have that base to those exponents added together. So for multiplying things that have the same base, we're going to add the exponents. Now the next one, if we have something to a power, to another power, in this case we multiply those exponents. So a to the m to the n, a power to a power, means multiply the exponents. Now, if we are dividing, it's going to be kind of the opposite of what multiplication was. When we're multiplying things that have the same bases, we added the exponents. If we are dividing things that have the same bases, we're going to subtract the exponents. All right, now our next one here, if we are multiplying in parentheses two numbers, and they're to a power on the outside of the parentheses, we can distribute that power to both terms. This is only if these terms are being multiplied. If the things are being added, a plus b to the n, that does not equal a to the n, b to the n. Don't do it, or plus. That's not true. Okay, so it certainly wasn't true where they were being multiplied, and it's still not true that you can distribute the exponent if the things inside are being added. If they're being multiplied, go for it. That's perfectly legal. And our last property, let's very similar to the multiplication one. If we are dividing two numbers, and there's an exponent on the outside of the parentheses, we can distribute that exponent to both of the numbers being divided. Again, totally legal. These are your 6 properties. Anything to the 0 power is 1, so long as that anything is not equal to 0, because that is not well defined in the math community, and it's not something we need to worry about in this course. When you are multiplying something with the same base, you add the exponents. If you have a power to a power, you multiply the exponents. If you are dividing things with the same base, you subtract the exponents. If you are multiplying two numbers in parentheses and there's an exponent on the outside, you can distribute that exponent to each of these numbers. You cannot do that when there's an addition between, only when multiplication. And finally, when you are dividing two numbers to a power on the outside, you can, again, distribute that power to each of the terms on the inside of the parentheses. All right, you know what time it is? It's example time. Just kidding. One other thing I want to talk about, negative exponents. Negative exponents. So if you have something to a negative exponent, that is equal to the reciprocal of that base to the positive exponent. So that is equal to the reciprocal would be 1 over 7 to the positive exponent. And then I can use this property right here, distribute that exponent to each part. 1 squared over 7 squared is going to be 1 over 49. So a negative exponent is equal to the reciprocal to the positive exponent. So let's make this a fraction just for funsies and say that's to the negative 4. That is equal to the reciprocal 3 over 4 to the positive exponent. Nope, 3 over 2. I can't just change the number all willy-nilly. Which would be equal to 3 to the 4 over 2 to the 4. 3 to the 4, 3 times 3 is 9, times 3 is 81 over 2 to the 4, 2, 4, 8, 16. So, again, a negative exponent is equal to the reciprocal to the positive exponent. Now let's do some examples. All right, here we go. We'll start with a simple one. 2 to the negative 3. That's equal to the reciprocal 1 over 2 to the positive exponent cubed. Now I can cube each part. I don't need that parentheses, so bye-bye. 1 cubed over 2 cubed. 1 cubed, that kind of looks like 13, but you heard my words where I said cubed. 1 to the third power is 1. 2 to the third power is 8. And that's as good as we're going to get, folks. Et voila. Next one, negative 3 over 4 to the negative 2. Again, this is going to be equal to the reciprocal to the positive exponent. I don't do anything with that negative. That negative is going to stay right there. So negative 4 over 3 to the positive exponent 2. So then I've got negative, and I can distribute this exponent to both parties. Negative 4 squared over 3 squared is going to equal negative 16 over 9. Again, my reciprocalness does not impact that negative out in the front whatsoever. All right, and now we've got this long monomial. What is a monomial? A monomial. Mono means one. It is a single term. So our monomial was a single term. I'm not adding, I'm not subtracting, I'm just multiplying all these things together. So this is a single term. All right. I can, I see a negative exponent. I know that's equal to the reciprocal to the positive exponent. So this is actually equal to negative 4 times 1 over x to the positive 3 times y to the 5th squared. Oh, I don't like that at all. I don't like that at all. I can make all of these over 1 as well, and then multiply the numerators and the denominators together. So let's just make this negative 4 times 1. That's fine. That's negative 4. Y to the 5th on the top, and then we'll have x cubed on the bottom. That is much more pleasant than this nonsense. And now, let's distribute that power to each of these components. So we will have, slide that up there, negative 4 squared, y to the 5th squared, over x cubed squared. Everybody's getting squared. Negative 4 squared is, of course, 16. Y to the 5th squared. What do we do with these powers? We multiply them. That's going to be y to the 10th. Same thing down here, x cubed squared. That means we multiply 3 times 2 to get x to the 6th. Great. All right. Our last thing I want to talk about is multiplying monomials. Multiplying single term things using all of our exponent rules. All right, so we've got 2ab to the 4th, c to the 3rd, all of that cubed, and times 3b to the negative 2c squared. Okay, cool. So let's take this first one. Let's distribute our cubed to all of these parts. 2 cubed. I'm just going to write it out as I talk. So 2 cubed is 8. A cubed is going to be a cubed. B to the 4th cubed means we multiply the 4 times the 3 to get b to the 12th times c cubed means we multiply 3 times 3 to get c to the 9th. All right, great. All of that is going to be multiplied by 3b to the negative 2. Oh, I don't like that. Let's make that positive. That's going to be 3. The b squared is going to go on the denominator, and c squared will stay there. Okay, great. Remember, all of this is in the numerator, so that's what's going to get multiplied by the 3c squared here. We can multiply the numbers in front, multiply the constants. 8 times 3 is 24. A cubed times, okay, I don't have to worry about the a's because that's the only one. A cubed, b to the 12 on the top times nothing on the top, so I'm going to leave that there. C to the 9th times c squared. Now I have bases being multiplied with different exponents, so I'm going to add these exponents to get c to the 11th. All over, I've got b squared in the bottom. Now when I'm dividing things that have the same base, I subtract the exponents. So this is going to be 12 minus 2 to get 10. So our overall answer, 24a cubed, b to the 10, c to the 11. Fabulous. All right, next one. I've got negative 2, x to the negative 2, y to the 5th, all to the negative 2. Oh goodness. All right, let's fix the inside and then we'll do the reciprocal here. So this is going to be equal to negative 2. Remember, that's not an exponent that's negative, so that negative 2 is going to stay as negative 2. This x squared is going to go to the denominator, and the y to the 5th will stay in the numerator. I should extend my parentheses. Okay, so that's to the negative 2. Now let's make this into a positive exponent by doing the reciprocal here. So everything in the numerator is going to go to the denominator. So this is going to become x squared on the top. Negative 2, again, still negative 2. Y to the 5th in the denominator, all that to the positive 2. And then we can distribute our exponent to each part. X squared squared on the top is x to the 4th. Negative 2 squared. I'm squaring the whole negative 2 here, so that should be positive 4. If the negative would have been out in front of the parentheses, that would mean I would square the 2, and then I would make it negative in the end. But I'm squaring the whole thing inside the parentheses, so I'm squaring the whole negative 2. And y squared, nope, y to the 5th squared means I multiply these exponents to get y to the 10th. Very good. All right, we're going to do one more. Last one, let's make it wild. We've got a fractional term here with a negative exponent, so let's fix the inside first, and then we'll do the reciprocal, and then distribute. So anything that is a negative exponent needs to go to the opposite side of the fraction here. So these guys are going to switch. So, oh, also, what do I see? X to the 4th and x squared. I can simplify that in here too. This means we're subtracting. So 4 minus 2 is going to be 2 on the top. Let's do that. So we'll have x squared on the top, z to the positive 1, 3 in the denominator, and y squared. All of that is to the negative cube. All right. So now let's rewrite this as the reciprocal to the positive 3 power. So we'll have 3y squared in the top, 2x squared z in the bottom to the positive 3. And then I can distribute the cubed to all the parties. And we'll do 3 cubed is 27. Y squared cubed means I multiply these to get y to the 6th. 2 cubed is 8. It's my favorite number. I love the number 8. It's delightful. X squared cubed means I multiply these exponents to get x to the 6th. And z cubed is just straight up z cubed. All right, lovelies. That is it. Let's do a quick little recap. What did we talk about today? We talked about properties of exponents. There were 6 of them, 6 properties of exponents. We talked about what it meant to be a negative exponent. It is equal to the reciprocal to the positive exponent. We talked about using those properties. We said a monomial is a single term, and then we multiplied monomials. Wonderful. Love you, scholars. You're doing great. Keep on that hustle, and I can't wait to see you next week.